Have you ever stopped to think about something like a giant skyscraper, or maybe a factory, or even a data center? I mean, these places use an insane amount of electricity. So how do they get all that power where it needs to go without it becoming a complete and total bird's nest of wires? Well, the answer is this amazing and kind of hidden piece of engineering.
And that piece of engineering is called a busbar. So in this explainer, we are going to follow its journey, all the way from just a raw hunk of metal to the finished conductor that, and this is no exaggeration, powers our modern world.
Here's our game plan. First, we'll talk about what a busbar even is, this hidden superhighway. Then, we'll trace its entire manufacturing journey. We'll get into the incredible precision needed to make one, and finally, we'll see why getting it right matters so much. Sound good? Let's dive in.
All right, let's start at the beginning. What in the world is this hidden superhighway for electricity? This slide really says it all. On one side, you've got your traditional wires. Think of it like a messy web of city streets during rush hour. It gets congested, things get hot, and it's just not built for that much traffic. But on the other side, you've got the busbar. It's clean, it's simple, it's a superhighway, built for one thing, moving massive amounts of power, smoothly and efficiently.
So what is it exactly? Well, at its core, a busbar is just a solid strip of metal. It's not a bunch of tiny wires bundled together. It's one thick, beefy conductor that acts like the main artery for electricity inside a power panel or a massive switchgear. It's just the perfect blend of simplicity and raw strength.
And those advantages are a really big deal. Because it's a solid bar, it can handle enormous currents with very little resistance, which means less energy is wasted as heat. Plus, that large flat surface area is great at cooling off. For the folks doing the installation, it means everything is cleaner, more organized, and a whole lot safer. It's a total game changer.
Okay, so we know what they are and why they're so important, but how do you actually turn a simple piece of metal into one of these high-performance conductors? Let's follow the journey.
The whole fabrication process is really a masterclass in precision engineering, and it boils down to these 5 key steps. You start with the right material, you shape it by cutting, punching, and bending it, and then you add the crucial finishing touches that make sure it's safe and built to last.
Step 1 is all about the material, and let me tell you, copper is the king here. It's just fantastic at conducting electricity and handling heat, which makes it the go-to for pretty much everything. But aluminum definitely has its place. If weight is a big issue, or if you're trying to manage costs, aluminum is a really solid alternative.
Next, that raw bar of metal gets cut down to size and punched with holes. And this isn't just a rough estimate. We're talking about extreme precision. The length has to be absolutely perfect to fit into the panel, and those holes need to be in the exact right spot for all the connections. One tiny mistake here can throw the whole system off.
Now, bending, this is where the busbar gets its unique personality. Electrical panels can be these incredibly crowded, complex 3D puzzles. Bending is what allows the busbar to snake its way through that maze, twisting and turning to connect all the different points in the circuit. It's kind of like a mix of pure engineering and sculpture.
And finally, we have the finishing touches. Deburring is super important. It gets rid of any sharp edges, which is a huge safety feature. Polishing makes the surface smooth, and then there's plating. This is key. A thin coating of another metal, like tin or silver, is added to prevent corrosion and make sure you have a rock-solid electrical connection for years and years to come.
Okay, so making all these perfect cuts, holes, and bends over and over again, especially on thick bars of metal, that takes a lot more than just a good eye and a steady hand. It takes some serious technological firepower. And let's be real, when you're talking about the power systems for hospitals or massive data centers or busy factories, there is zero margin for error. A bad connection isn't just an inconvenience, it can be an absolute catastrophe.
And that's exactly why the industry relies on incredibly advanced automated machines to do this work. It's the only way you can guarantee the kind of precision and consistency that these critical systems absolutely demand.
So what kind of tech are we talking about here? Well, you've got CNC machines, that's computer numerical control, that use digital plans to cut and punch with microscopic accuracy. Then you have massive hydraulic benders that can apply the tons of force needed to bend thick copper like it's clay. And some of the coolest machines are these 3-in-1 processors that do all of it, cutting, punching, and bending in one seamless, super efficient operation.
So we've covered the what and the how, but let's bring it all home. Why does all this painstaking, precise fabrication actually matter in the big picture? Well, first and foremost, it's about efficiency.
A properly made busbar is incredibly good at its job, like over 99% efficient. That means almost no electricity is lost as waste heat. When you scale that up to the size of a data center, that translates into an enormous amount of saved energy and money.
And that incredible efficiency leads directly to long-term savings. A well-fabricated busbar isn't just efficient, it's also unbelievably durable. That means less maintenance, fewer costly replacements, and a much better return on investment over the entire life of the system.
You can really see the ripple effect it has. Automating the process makes production faster and brings down labor costs. The modular design means a company can expand or change its power systems pretty easily. And that durability we mentioned means you're not constantly spending money on replacements. It's just smart economics built on a foundation of smart engineering.
And the story isn't over. This field is always evolving. People are developing things like advanced nano coatings to make busbars even tougher against corrosion. And now, by embedding tiny IoT sensors, we can actually monitor these systems in real time, predicting when maintenance is needed before something ever goes wrong.
So, the next time you flip a switch or see the lights on in a giant building, think about the busbar. Think about its journey from a simple metal bar transformed by incredible precision into an electrical superhighway. It really makes you wonder, doesn't it? What other invisible engineering marvels are all around us, quietly making our world work?